question 7, we need to find the coordinates of the points on the curve defined by this equation here, in which dy by dx is equal to 0. So as you can see, this equation is not given explicitly y equals something, so we haven't had y defined explicitly in terms of x, so that just means we don't have y on the left hand side equals and then some expression on the right hand side solely in terms of x. So we're going to have to use implicit differentiation, which is where we treat y as a function of x and differentiate with respect to x by applying the chain rule. So for the first part, y cubed, we're going to end up with 3y squared, and then applying the chain rule times that by dy by dx. And then for this 3xy squared, we're going to have to apply the product rule as well. So if we differentiate just that 3x in terms of x, we're going to get 3 times y squared plus, then we're going to get 3x, and then differentiate this y squared, so we're going to get 2y times dy by dx, and then this minus x cubed, well, that's solely in terms of x, so that's straightforward, and that is going to be 3x squared, and differentiating any constant, which is going to equal to 0, so that 27 goes to 0. And now we can just tidy this up a little bit. So we've got this dy by dx occurring here and here, so we can factor that out. So we have dy by dx times 3y squared plus, or 3x times 2y is just 6xy, and that's equal to, well, I'll take this negative 3x squared over to the other side, so we're going to equal 3x squared, and then I'll take this 3y squared over to the right hand side, so we get minus 3y squared. And now it's just a matter of rearranging and simplifying. So we get dy by dx is equal to 3x squared minus 3y squared all over 3y squared plus 6xy. Okay, and now we can factor out 3. That's equal to 3 x squared minus y squared over 3 y squared plus 2xy, and therefore we're going to get dy by dx is equal to x squared minus y squared all over y squared plus 2xy. So the question is asking us to find the coordinates of the points on the curve at which dy by dx is equal to 0. So if we set this expression here that we've got, we'll set that equal to 0 and go from there. So setting that equal to 0, we now get x squared minus y squared is equal to 0, just timesing both sides by that denominator there, y squared plus 2xy, and therefore we get x squared is equal to y squared, and therefore taking the square root of both sides, x is equal to plus or minus y. Okay, so don't forget to take the positive and the negative when we square root. So we've got two cases. We've got the case where x is equal to positive y or x is equal to negative y. So if we just come over here, so if x is equal to y, well then we're going to get y cubed. We're just substituting back into this expression here. So we're going to get y cubed plus, well, 3xy, so wherever we see an x, we'll just put a y, because x is equal to y. So we get y cubed plus 3y cubed, and then minus x cubed, so minus y cubed, because y is equal to x, is equal to 27. And simplifying that down, we've got what, 3y cubed plus y cubed minus y cubed, so that is equal to 3y cubed is equal to 27, and therefore y cubed is equal to 9, and so y is equal to the cube root of 9. And as x is equal to y, therefore x is equal to the cube root of 9. So that's one set of coordinates, and the other situation is we had if x is equal to negative y. Okay, so wherever we see an x, we'll just substitute in negative y to that equation that was given in the question. So that means we're going to get y cubed, and this time, y cubed, and this time it's going to be minus 3y cubed, and plus, it's negative, plus y cubed is equal to 27, and so we're going to get negative y cubed is equal to 27, so y cubed is equal to negative 27, and therefore y is equal to negative 3, and x is equal to negative y, so therefore x is equal to 3. Okay, and so there's our two sets of coordinates. So our coordinates are, well, we've got cube root of 9 and cube root of 9, and we've got x is equal to 3 and y is equal to negative 3. Okay, so we have now found the coordinates of the points on the curve of the equation at which dy by dx is equal to 0.